All right, we've already looked at some division of polynomials. We've looked at bimonomial, so we're done with that. We've looked at long division, so we're done with that. Now we're going to look at synthetic division. Now one note that this only works if you're dividing by a linear polynomial, meaning at most it is degree 3, and the leading coefficient has to be 1. So, for example, if you had something, something, something divided by 3x plus 1, this would not work because your leading coefficient is 3. So that one does not work. Let's say it was something, something, something divided by x squared plus 1. Again, does not work because the degree is larger than 1. It would have to be something, something, something divided by x plus 1. Now this works. Leading coefficient is 1, degree 1. Now it will work. These are the steps to follow if you are going to do synthetic division. Number 1, you're going to start by drawing an upside down division box. And I'll show you what this looks like when we do an example. Next, you're going to write the opposite of the constant, or the divisor, outside the box. So again, whatever you're dividing by, if it's x plus 5, you're going to put a minus 5 on the outside. Then you're going to write the coefficients of the dividend inside of the box. I'll show you again what that looks like. Next, you'll bring the first coefficient straight down to the bottom or below the box. You'll multiply the constant, the one that was outside the box, by the number on bottom, and put that product back inside the box, underneath the next coefficient. Then you'll add the next coefficient with that product, and you put the sum below the box. Multiply the constant by the number, and put the product in the box, and repeat that process. You'll notice that 5 and 7, it's already starting to repeat. Repeat that process until you've used all the coefficient. Once you're at the end then, the rightmost number that's underneath the box counts as your remainder. The next number to the left is the constant of the answer. The next number to the left is the degree 1, then degree 2, and so on. I know these steps are kind of confusing and kind of goofy. It's best just to watch it pan out. So, we are going to try dividing with synthetic division. Now first I want to show you that if I divide by this polynomial by a linear, again notice degree 1, coefficient 1, we've already seen this example in long division. Your answer should come out to, x minus 2. So we know already this is going to come out to x minus 2. So I'm going to show you that we can get there using synthetic division. Same exact problem, x squared plus 3x minus 10 divided by x plus 5. So again, we start by drawing the box, only it's upside down. We have the side here, but instead of this going on top, this is going to go underneath. Instead of using x plus 5, we use the opposite of that constant. So instead of a plus 5, we use a negative 5. And whatever coefficient was out here, we drop that straight down. So coefficients 1, 3, and negative 10 go here. The 1 comes straight down. Now negative 5 times 1 becomes negative 5. And notice that that's underneath my next coefficient. Again, coefficients were 1, 3, negative 10. That's where these came from. After I drop down the 1, negative 5 times 1 is negative 5, underneath my 3. Now I go 3 plus this negative 5 to get negative 2. Negative 5 times negative 2 is positive 10. That goes here. Negative 10 plus 10 becomes a 0, and now I've used all of my coefficients. So at this point, I know that my remainder is 0. Next number to the left, I know my constant is negative 2. Next number to the left, I know my degree 1 is 1. What that looks like then is I have 1 x to the first power, that was right here. I have negative 2 x to the 0th power, or constant, right here. And I have 0 for my remainder, so plus 0 over this, remember, would be my divisor, so this should be my denominator if this was a remainder. Because it's 0, I don't have to worry about it. So instead of writing it this way, though, I can just simplify it to x minus 2, which again, that's exactly what we found when we did long division. So you can either do the long division or the synthetic division. Either one works as long as this is a linear with at most a leading coefficient of 1. Let's try another using synthetic division. X squared plus 3x minus 4 divided by x minus 1. Now again, notice minus 1, we want the opposite of it, so we want a plus 1 out here. Coefficients are 1, 3, and negative 4, so 1, 3, negative 4. I've got my constant, I've got my coefficients, I've got my box. First thing I do is drop down the first coefficient, 1. 1 times 1 is 1. 3 plus this 1 makes 4. 1 times 4 makes 4. Negative 4 plus 4 makes a 0. Now I've used up all of my coefficients. So these are the numbers of my answer. My remainder is 0. My constant is 4. And my degree 1, the coefficient is 1. So again, it'll look something like this. 1 goes with x. 4 goes with x to the 0th power, or again, that's my constant, and 0 is my remainder. So we'd say that answer is just x plus 4. So x squared plus 3x minus 4 divided by x minus 1 equals x plus 4. Let's try another one with synthetic division. Again, this time we're going to show with a little bit more. We have 4 terms here divided by, again, just this linear. So again, we have x minus 2, so I need to make sure I do the opposite. Plus 2 is on the outside of my box. The coefficients here are 1, negative 11, positive 10, and positive 16, so those go inside my box at the top. I have enough space underneath for me to write. First thing I do is drop down this 1. Now I go 2 times 1 makes 2. Negative 11 plus 2 makes negative 9. 2 times negative 9 is negative 18. 10 plus negative 18 comes out to negative 8. 2 times negative 8 makes negative 16. And 16 plus negative 16 comes out to a, 0. So again, here are my coefficients. 0 is my remainder. Negative 8 is my constant. Negative 9 is my x term. And 1 is my x squared term. So each of these takes a place. Remainder, constant, x to the 1, x to the 2, and so on. And again, if there were missing pieces up here, just like with long division, you would have to put a 0 in its place here. This one didn't have that. We just have all these pieces, and we can simplify it to x squared minus 9x minus 8. So this polynomial divided by this polynomial will come out to this polynomial. Let's try another one with synthetic division. Now I cheated. I used this exact same one, only instead of the 16, I put a 21 here. That makes sure I know that there will be a remainder. So we're going to do the same exact setup. Negative 2 or minus 2 over here means that we have to have a positive 2. Coefficients of 1, negative 11, 10, and 21. 1, negative 11, 10, 21. Drop down my first coefficient. Now, 2 times 1 is 2. Negative 11 plus 2 is negative 9. 2 times negative 9 is negative 18. 10 plus negative 18 makes negative 8. 2 times negative 8 is negative 16. 21 plus negative 16 makes a positive 5. So in this case, I do have a remainder. I have a remainder of 5. So I need to look at what my Divisor was x minus 2. So when I write this out, 5 over x minus 2. That was my divisor. Here was my remainder. Remainder over divisor. My constant is still this next number here, minus 8. My degree 1 was this one, and my degree 2 was this one. So x squared minus 9x minus 8 plus 5 over x minus 2. Again, you can simplify this to look something like this. X squared minus 9x minus 8 plus 5 over x minus 2. So that'll end it for our third video. Again, in this video we discussed dividing polynomials using synthetic division. At this point you should know how to do adding, subtracting, multiplying, and dividing with polynomials.